Welcome everyone. In this video we are going to learn about another informed search algorithm, which is A* algorithm. It is a very famous algorithm that is used in artificial intelligence. Now these are some of the features of A* algorithm. It uses heuristic function h of n and cost to reach node n from start stage g of n. So basically, in simple terms, if you want to say what is A* algorithm, since it is informed search, so obviously some information will be given about the graphs from beforehand itself. So here we need to compute the f of n function, which is equal to h of n plus g of n. Now what is f of n? It is the fitness number or estimated cost. H of n is the heuristic value. Heuristic value means the cost that is required to go from one node to the goal state, and g of n is the cost to reach the node. So from the start node, from one node to reach this particular node n, what is the cost? Okay, using a graph we can explain this h of n and g of n in a more proper way. Now this A* algorithm, it uses the combined features of uniform cost search. Uniform cost search is a uninformed search. We have already discussed it in previous video. So it combines the best features of UCS and greedy best first search. So greedy best first search we have already discussed in previous video. So the best features of both these algorithms are combined in A* algorithm. It finds the shortest path through the search space using the heuristic function, that is h of n. It expands less search tree and provides optimal result faster. So among all the informed search, A* algorithm is considered to be one of the best algorithm. This is the algorithm of A*. So here total 6 steps are there. So you can go through all the steps one by one. So I will try to explain this algorithm directly with the help of an example. The steps that we will be following in the example are exactly given here. You can compare it. What are the advantages of A* algorithm? It is the best algorithm than other search algorithms that we have discussed till now. Then it is optimal and it is complete. Complete means what? It is definitely going to give you a solution, and optimal means it is going to give the best solution. It can solve very complex problems. Then disadvantage, it does not always produce the shortest path, as it mostly based on heuristic and approximation. So since this A* algorithm depends on the heuristic function, so if there is some mistake in the heuristic function itself, then it may not produce the shortest path. So it will definitely give the shortest path if the heuristic function is correct. Okay, then it has some complexity issues, and the main drawback is memory requirement, as it keeps all generated nodes in memory. So whatever nodes will be processed or explored, everything is kept in memory. So it requires a lot of memory. So it is not very practical for various large scale problems. So if the size of the problem is very large, then it will require a lot of memory. So practically it is not possible. Let's see the performance of this algorithm. First of all, I have already told it is complete, and whether it is complete or not, it depends on what? Branching factor is finite. Branching factor should be finite means, what is branching factor? The number of nodes that a particular node can have. So if the particular node has a finite number of children or nodes, so then it is known as branching factor is finite. And the cost at every action is fixed. So whatever cost is taken to perform an action, it should be fixed. It should not keep changing. Then only the A* algorithm will give you complete results. Then optimal. Optimal means it is going to give the best solution if it is complete. Then time complexity and space complexity is big O of b to the power d, where b is the branching factor. Branching factor means number of nodes that a particular number of children that a particular node can have, and D is the depth. Now let us take one example and explain this A star algorithm properly. Consider this to be the graph. So we need to find out the using A star algorithm the path from S to D. So S is the let S be the starting node and D be the goal node. So we need to use A star algorithm. Now we see that this is the some numbers are given here. So from S to A one number is there. So what is this? This is G of n, that is the cost of the, in the theory part we have seen it is G of n. G of n is what? The cost to reach the node. So the cost that is needed to come from this node to till this node, from started node till this node is 1. So this is G of n, and one more value is attached here. So what is this? This is H of n, that is the heuristic function. It means the cost that it takes from to go from node A to goal node. So it is 6. So for each of the nodes the heuristic functions are mentioned. So now we need to calculate the f of n for each of the nodes. So what is f of n? F of n is G of n plus H of n. So f of n is heuristic fitness number or estimated cost, which is equal to G of n, that is the cost from to reach a particular node, and H of n, which is the heuristic function, that is the cost to reach the goal node. So so we are going to start from S. So we will have to find all the cost of all the nodes that are adjacent to S. So what are the nodes adjacent to S? A and B. So first we are going to calculate the cost to reach from S to A and S to B. Now what is the cost for this one? To reach from S to A, it will be G of n plus H of n. So S to A, so what is G of n here? G of n is 1, and what is H of n? 6. So 1 plus 6 is equal to 7. Now to come from S to B, what is G of n? 4, and what is H of n? 2. So 4 plus 2 is equal to 6. Okay, so we have explored all the child nodes of S. Now which node to explore first? The one that is having the less value. So 6. So let us explore this path. Okay, so we are in S to B. We are going to explore this node. So from B, where we can go? From B we can go to C. No more nodes where we can go to C only. So we will try to find what is the cost. So what is the cost? The cost is, so first we will have to find out G of n, that is the cost to reach this particular node. So we are following this path. So 4 plus 2. So 4 plus 2 is the G of n, and what is H of n? 1. Now what is the total cost? 4, 5, 6, 7. Okay, now both these we will have to keep on giving tick if we complete the when we explore a path. Now out of these two paths we can take any path because the cost is same. Since we are continuing with this, let us take this one. You can take this one also. So we will have to continue this path till we reach the goal node. So we have explored till here. Now from C, where we can go? So from C we can go to D, which is the goal node, right? So what is the path here? First we will calculate G of n. 4 plus 2 plus 3. So it is 4 plus 2 plus 3, and then what is the H of n here? 0. So total it is 4, 5, 6, 7, 8, 9. Okay, now after this we are not going to explore any further because this is the goal node. So since we have reached the goal node, so we will mark this one. So this will be considered as one of the path, but yet we need to explore all the paths. So we will explore this path now. So S A. So from A, where we can go? From A we can go to B, we can go to C, and we can go to D. So we will write all these things. From A we can go to B, then we can go to C, and we can go to D. So let us write it like this. And then we will calculate the fitness number for all this. Now for this path SAB, what is the cost? S1, 2, SAB, right? So 1 plus 2 and then 2. So 1 plus 2 is the G of n, and H of n is 2 again. So it is equal to 5. Then this one, now we will see this one, SAC. SAC. For this, 1 plus 4. 1 plus 4 is the G of n, and H of n is 1, which is equal to 4, 5, 6. Then we will calculate SAD. SAD, it is 1 plus 12. 1 plus 12. And what is the H of n? It is 0. Now it is equal to 13. Now obviously this part we are not going to explore anymore because we have reached a goal state. So this can be considered to be one of the path. Okay. Now we need to explore this or this. Now 5 is less, so we are going to explore this path. So let us explore S A B. So from B, where we can go? SAB, we can go to C. So what will be the cost? SABC. SABC. So 1 plus 2 plus 2. 1 plus 2 plus 2. What is G of n? Sorry, H of n? 1. So total cost it is 3, 4, 5, 6. Okay. Then from C again we can go to D. So again this we will continue with this path. So we will give one tick here. S A B C and D. So what is the total cost here? SABCD. SABCD. 1 plus 2 plus 2 plus 3. 1 plus 2 plus 2 plus 3, and here H of n is 0. So it is equal to 1 plus 2, 3, 4, 5, 6, 7, 8. So 8. So here we have reached a goal node. So again this can form as one of the paths. Okay. Now we need to explore this path left, right? The rest we have all, this one also we have explored. So I forgot to give tick here. So this path only left. So let us explore this path. S A B S A, no, SAB we have explored. SAC, sorry, SAC. So from SAC, where we can go? SAC. From here we can directly go to D. So this one will be equal to what? SACD. 1 plus 4 plus 3. 1 plus 4 plus 3. And then what is H of n? 0. Now this is equal to 4, 5, 6, 7, 8. Right? SACD. 1 plus 4 plus 3 plus 0. So this we have already explored, so we will give a tick here. So this can be a goal path. We can consider this to be a path also, because this is also including D. So after this we don't have any more paths to explore. So now what are the paths that we have got? This is one path, this is one, this is one, and this is one. So now out of these we will consider the path having the lowest cost. So this or this. So either we can choose this path or we can choose this path. It is going to give the minimum cost, which is 8. So this is all about A star algorithm.